Welcome to Out of This World. I'm Matthew Nicolantonio with meteorologist and science writer Scott Sutherland. Today we are going to be discussing the International Space Station. Maybe something that a lot of folks maybe take for granted a little bit about how, considering how close it is, how valuable it is, and all the research that it does for us. So let's start with a little bit of a history lesson.
Sure.
The International Space Station, not really the first of its kind, and not even really the first sort of North American one.
Right.
So let's, before we get really into the International Space Station, what were some of the precursors to the ISS?
Right. So the very first space station ever in Earth orbit was way back in 1971, the Russian or Soviet Salyut 1 station. It was only up for a very short amount of time, like 50 days or something like that, and it was only inhabited for even shorter time. But with the U.S. launch of Skylab in 1973, there has always been a space station in orbit of Earth. It always hasn't been the same one, but there were a total of 6 Salyut stations that were existing at certain points in that timeline. The Skylab was 73 through 79, I think, or even later than that. And yep, that was 79. And then there was Salyut stations up into the 90s. But then we had Mir from them as well. That was from up until 2001. And the first section of the International Space Station launched in 1998. And it has been continuously inhabited since the year 2000. Up until now, it's much, much bigger than it was to start off with. It was just one section called Zarya at the time when it first launched. And now it's there's I think a dozen different from not only the Russians but from the U.S., from Japan as well.
I did want to touch on that. So it's the International Space Station. Who are all the countries that have contributed to what's up there right now?
It's basically, the station is a collaboration between the U.S., Canada, Russia, and the European Space Agency and the Japanese Space Agency. And there have been astronauts from the U.S. and Russia, from Canada, from Japan, Germany, Italy, Denmark, and France, and the U.K.
And there's been like hundreds of astronauts that have gone up.
Yeah, we're talking
and had missions there.
Yeah, 270 plus, close, almost 300 now we're going on. And it's been up there for 25 years, continuously inhabited for 23 years. I mean, there's been a lot going on up there.
So what was sort of the original idea behind the mission to have a station constantly orbiting the Earth?
Right. So in some cases, it was simply like an expansion of what was going on with the Apollo program and with the Russians' counterpart to those programs. Then Skylab, as its name implies, was a scientific laboratory, and all of them have had a scientific part to their mission. The ISS especially so. Because it is solely a scientific laboratory in space, in orbit, to basically find out how zero-G impacts various aspects of our lives, of our technology, of finding out what it takes to have humans be able to stay in space longer, more comfortably, be more healthy while they're there. But it has a lot of applications back here on Earth as far as the technology goes that has been developed to go into the space station, has come back to help us here. We wouldn't have the modern cell phone, the modern smartphone, if it wasn't for the programs and the technological advancements that went into making the space station what it is today. But it also has impacts on medicine and so forth. But yeah, it's a scientific laboratory, and it has always been so, the ISS. It's the only stipulations is that none of the science that goes into what's being studied there can have a military operation. It is an international collaboration for peaceful use of scientific investigation and for the benefit of humanity.
And so we've mentioned orbit. It is constantly orbiting Earth, right?
Yep. It goes around the Earth once every 90 minutes or so, roughly. And its exact distance from the surface of Earth changes, but it's usually in the high 300 kilometer range to low 400 kilometer range.
Okay.
So it's really not that far away from us
It
when you
doesn't
really
feel
think
that
about it.
far away.
No,
Yeah.
400 kilometers is really
Yeah.
not that far away.
That's like
So
Toronto to Ottawa, not even.
exactly, right? So, but in terms of remoteness, it's one of the remotest places
Right.
that exists.
You were going to say on Earth. It's
Oh,
not
I
on
was going
Earth.
to say on Earth, yeah, because it is such an intricate part of
Right.
what we're doing here, right,
Right.
on Earth. So, yeah, but it's one of the remotest places that we have access to right now, and that comes into play with the scientific investigations as well. Like, there have been technologies, and I believe it was a Canadian invention, where it was a remote medical diagnostic tool that they sent to the space station, because this was originally intended to be like, we'll send it to remote places of Earth. We'll send it to people that are living in Antarctica, at the research stations there. We'll send it to the Arctic. We'll send it to Asia, to Africa, to all these places that have a lot of space between communities,
Right.
and maybe less access to medicine than they need. And they wanted to study this technology in a remote location, and that was a perfect remote location to send it to get, pretty much the most remote access to people that you could have, except in the actual field here on Earth.
What's we talk about the distance. How long does it take to get to there?
That depends. The Russian launches with the Soyuz program, those take maybe a few hours to get there. I believe there's even a faster route to get there, but usually, like if SpaceX launches up there, or if NASA launches some other way of getting up there, that's usually, it goes up, your spacecraft goes up, goes into orbit, sort of orbits around the Earth a few times and chases the station until it catches up, and then
It's a
it
little
docks.
game of cat and mouse.
Yeah, whereas the Russians very, very closely time when the space station is passing overhead and launch right on time, so that they can go directly to the station rather than orbiting around Earth first.
Is there a reason why they do that and others don't?
It's mostly just another way of doing it, so that if there are time-sensitive things, like you need to get parts up there that on an emergency basis, you need to get people up there on an emergency basis, or if there's sensitive science that's being sent up at the same time, you have a fast route to get there. It's also for comfort for the astronauts of not having to be in that cramped space of the space capsule for more than a day or two to get to the station. It offers a much, much faster route, so that it's just more comfortable for them when they get there. Yeah.
All right. As far as, it's been up there for a long time. Is this something that is going to continue indefinitely? Are there plans for renovations or even a new version of it based on what is there right now?
So there is a timeline right now for the end of the space station's mission. That is it is scheduled to be deorbited in early 2031, where it will splash down somewhere in the remotest area of the Pacific Ocean. It's called Point Nemo. And that's where it's like the spacecraft graveyard there, where a lot of satellites and spacecrafts crash down. And up until that point, I mean, it will probably be completely abandoned maybe the year before that, and then it will be allowed to deorbit. But up until that point, they plan on still using it. I believe there are still components, like modules, that will be sent up to it, mostly in the form of new modules to test what we can do with future space stations, like inflatable capsules on the sides of the station, so that you can add and subtract away from a station on a need-by-need basis. But up after that point, I mean, the Chinese have their Tiangong space station, which is currently in orbit and being composed of more advanced new technology than the 25-year-old ISS. For the most part, it may survive past the ISS's end date. But NASA kind of wants commercial spaceflight companies to sort of pick up the ball and go forward while they move out to the moon with the Lunar Gateway Station.
Right.
So once the ISS's mission ends, they're hopeful that already within the next 6 to 7 years, the commercial spaceflight companies will have sent up their own versions of space stations to take the ISS's place and continue that legacy of space science investigation and experimentation, because there is a business there that can easily be made. So continuing to have that access to that environment of zero G to do these science experiments might be critical for humans to continue to advance in spaceflight.
What's life like up there? It's we know that from the wingspan of the space station is about the length of a CFL football field, 110 yards.
Yeah.
So, and there's a living quarters, bedrooms, bathrooms, and sort of a workout area.
Right.
And we know that they need to be, I believe I read, working out 2 hours per day to maintain the adequate muscle mass while they're there. So what is life like on the International Space Station? Right.
Well, they're constantly under zero G. I mean, there's gravity pulling down at them all the time at that level, but they're basically in free fall as they orbit around the planet. So it feels like zero gravity. So it's called zero G. So you're constantly floating around. Even when you're sleeping, you're strapped into this little kind of almost like a little closet that you can zip up like a tent, and you hang in midair in your sleeping bag. I've been told it's the most comfortable night's sleep anybody ever gets. Because you're not dealing with lying on a bed.
Right.
You're just floating there, and you just go to sleep and you wake up in whatever, 8 hours, and you feel nice and refreshed. But but you're floating around. Food is always in like vacuum sealed containers. They've only recently been able to actually drink liquids out of a cup, like an open cup, because the interior of the cup uses capillary action, they call it, where you can pour a liquid in there, but the liquid will stay like rooted to the sides of the cup and it won't just float out.
Interesting.
So you can actually sip, like they made cappuccino on the space station. Of course they were able to sip it out of the
Italians were up there.
Exactly, right? So they were able to sip it out of these little cups rather than having to have the baggie with the nozzle on it that you squirt into your mouth. But that's usually what food and your drinking is like, is that everything's vacuum sealed. It's all like in bags, and you heat it up, yes, but it's all like mushed and mashed and so forth. They do get fresh food, like fruits and vegetables and so forth, that they can eat pretty much with every cargo ship that goes up. But of course, that's not going to last the entire mission. So eventually they're eating this freeze-dried stuff and so forth. They have to work out constantly every day, because the zero G will wear away at your muscle mass and your bones if you don't. It used to be that when you got back down from being on a 6-month mission on the ISS, that you would hobble around like you were 80, 90 years old. It would so deteriorate your muscles and your bones. But now you see the astronauts just walking along, like they land usually in Kazakhstan now, or off in Florida, off the coast of Florida, and then they get on the ship and they walk around like nothing's wrong, because they've kept up their exercise routine the whole time they were there. But yeah, it comes down to everything. All the air is recycled, all the water is recycled. They get constant resupplies all the time, like every 3 or 4 times a year. So they always have to keep busy. They're always busy with science experiments. How to grow food in space, because we're going to need that for future space missions. So they're growing lettuce and all these other vegetables up there to basically figure out, okay, well, what do we need to do that? Can we do it without soil? Do the plants have any other nutritional aspects to them? Does it affect their nutrients at all? Does it change them?
So in terms of experiments and expeditions, we've discussed robotic control. What other, you've mentioned very wide-ranging types of tests and experiments that they're doing. What else are they working on up there?
So some of it has to do with diseases, studying, because all the science that we have right up until the space station is basically what we can tell on Earth, in Earth's gravity and so forth. Anytime we can get out of that situation and have long-term experiments up in space going in zero G, we can get further information about microbes, about diseases, how they affect our bodies, how our bodies react to things, that just gives us sort of a different perspective on things and can actually further our knowledge about how diseases actually attack our bodies, attack the microbes, attack other things, the influences of medications and drugs, and actually creating new ones based on, because there are certain molecules and such when you're making chemical reactions and that actually come together in a different way based on the gravity. So if you can make chemicals come together in a different way up in orbit in 0G, that gives you another pathway to create medicines and drugs that can have a better impact on our health and have less side effects and so forth. But there's also how to grow food in space, because we're going to need that for future space missions. So they're growing lettuce and all these other vegetables up there to basically figure out, okay, well, what do we need to do that? Can we do it without soil? Do the plants have any other nutritional aspects to them? Does it affect their nutrients at all? Does it change them? Yeah. Also, how our body reacts to things like how 0G affects our vision, because it changes the shape of our eye, changes our vision, how long-term space flight affects how our muscles develop, how our bones change, how our circulation changes, and things like that, because we're going to need to know that if we're going to send people to Mars. We need to know the impacts of what's a 6-month mission to Mars going to do to the astronauts on their way there.
Is there any sort of weather observation or even a level of forecasting that can happen from there, or is it sort of too far away?
I don't know of any examples of them their photographs and such being used for that purpose. They do have astronauts that go into it's a cupola. It's a basically like a bay window that is always pointing down at Earth, and they take pictures. There's a website on NASA's website that you can actually go to that has the daily record of every photograph that's ever been taken from orbit from them. And the main scientific use for those images seems to be in things like studying disaster response, flooding, and so forth, where they will be able to compare before and after images of the same area that the astronauts took with their cameras, just to see how did things develop in the environment, but then also being able to coordinate disaster response based on those images. But other than that, weather forecasting and studies are usually done with orbiting satellites instead. But that is a resource that if we lacked those other methods, that could supplement it very easily.
Let's talk about Canada's contribution outside of astronauts. Probably most famously the Canadarm. I believe the Canadarm2 is attached to the space station right now. So let's talk a little bit about that, and then maybe pivot into the Canadarm3, which is scheduled to be a part of the next stage that we talked about, the Lunar Gateway Station.
Right. So Canadarm, the first one was for the space shuttles. I believe there were 2 of them, maybe 3. So they would be attached on the inside of the bay at the back of the space space shuttle, and would be used usually for deploying any satellites that launched them, like the Hubble Space Telescope. When they took that up there, they used the Canadarm to grab the telescope, draw it out into space, and then release it. Canadarm2 was put up on the International Space Station and actually helped build it, so that when the different modules arrived after it was installed, it would actually grab the module and properly bring it in to be attached. The space station, or the Canadarm2, can actually I'll put walk in air quotes. It walks along the surface of the station from end to end, basically on different attachment points, so that it can get to pretty much anywhere on the station to perform whatever they needed to do, whether that's to provide some other perspective on a section that may be damaged, or to grab and bring spacecraft in, like cargo spacecraft. But it also has a supplement to it called Dexter, which is kind of like an R2-D2 repair robot. that sits on the end of the arm. Doesn't always do it, but it will be there for any repair work that needs to be done, any support that it gives to the EVA astronauts that may be out doing a spacewalk, to make their jobs easier, basically. Canadarm.
Let's talk about Canadarm3 and the lunar gateway, and how sort of that is going to maybe differ from what the ISS, how the ISS operates and functions.
Right. So the lunar gateway is going to have a fairly similar structure overall to the International Space Station. Like, it will look different, obviously, but the components will be very similar to that one. You know, these tubular components that modularly lock together, solar panels and so forth. And the Canadarm2 or Canadarm3 will be one of the first components that goes up with it. And it will basically serve the same function. Most crewed spacecrafts now dock with the station instead of being berthed there. It's a slight difference where if you're docking, you just go right to it, and you, as the human-controlled aspect of it, or the computer on board your ship, automatically just lines up with the docking bay or the airlock and locks into it. To be berthed there, the ship just basically arrives, and the arm reaches out, takes a hold of it, pulls it into the right spot, and then attaches it to the station. So not sure which will happen for the gateway, but probably a mixture of both. So any cargo ships will be handled with the Canadarm3, and any human-piloted spacecraft will be handled with the computer or the humans on board. But yeah, it will serve basically the same purpose. But I believe it will be more advancements, because, I mean, Canadarm2 now is at least 20 years old. Right. So it'll be much more advanced, capable of more articulation, have more sensors on it, more cameras, and so forth. Haven't heard anything yet about a Dexter component to it, but might be something along those lines as well, or maybe just incorporated into it rather than having a separate system. But yeah, very similar overall design of this articulated arm that can reach any part of the station and perform multiple tasks to support the mission.
And finally, just let's talk a little bit more about the lunar gateway as a whole. Yeah. Obviously, the idea is, as we've talked about, the hope of sort of using it as a launching pad further into the solar system, or for making space travel easier. Will it still serve that same sort of research function as well?
I would think so. Yeah. It's such a valuable aspect to have that sort of science laboratory in place, but I think it will be mostly focused on the moon, studying what's going on the lunar surface. So it will be not only a waypoint to get people to the moon surface and back, possibly launching to Mars from there, or they might decide to go from the lunar surface instead, but still a support function for getting the materials there and organizing things. But mostly the science there, I think, will still be focused on the moon itself. So here in low Earth orbit, I believe that NASA's idea is that the commercial spaceflight companies will take the ball and go with it. Will put up their own space stations and create a low Earth orbit space economy where anybody can then send up experiments. If you're a company or you're a school or research scientists, to send up the same kind of stuff that's being studied now in the ISS, to study in their newer, more advanced, I suppose, science labs in orbit, and conduct that same kind of science, and possibly even move some manufacturing out into orbit in the future, because we may find that there are ways of creating materials that we can use either out in space or here on Earth that are actually easier to manufacture in zero-G, because we can combine the materials in new ways that we would never be able to do down here. Right. It's sort of the same leap forward that may come from what we were already seeing due to 3D printing, where you don't have to have a machined piece of metal that attaches to something else. You can actually 3D print something right off the bat that far surpasses any sort of machined technology that can be produced, and that may be that next level jump in technology that we get from constructing these things in low Earth orbit instead.
All right. Lots of exciting stuff happening here on Earth and out of this world as well. Scott, thanks so much for joining us.
Yeah, it's been great.
It's very pretty out here.